Good morning. This is Louis-François, co-founder of Towards AI, and today I'm sharing with you the first course of our 5-course series on Towards AI that is about upskilling any developer or pretty much anyone to AI or to working with LLMs. We will share tons of insights and things to know about LLMs that we believe are truly essential for LLM developers. The course is paid on the Towards AI Academy website. The link is below. Please enjoy this free 2-hour session and check out the rest on our website. Let's get to it. Good morning, everyone. This is Louis-François. I'm the co-founder and CTO of Towards AI, but I'll introduce myself and the second speaker, my colleague Omar Solano, in a few slides. We just wanted to start with a quick introduction on why we are here and why this course first. So this course, what is it? Well, it's called Operation and Development with Large Language Models. This is just the name of the slide, but it changed on the website, obviously. So the first session here is the foundational knowledge to know for working with LLMs. So why are we here? It's to learn large language models. Why? Well, it's for many reasons. The first one is because it's no longer just buzzwords anymore. Even though it's full of buzzwords like agents, agentic AI, generative AI, whatever, they are not just buzzwords anymore. We can do real things, real products, real applications. Here, just a quick example of what it can do. Just in recent reports, the company Klarna and Amazon both reported to save many millions of dollars thanks to artificial intelligence or language models, in this case, being implemented in their workflow. And likewise, it saves me and my team tons of hours. Another thing is that there are increasing ways to avoid mitigate errors, which we'll all cover in this course. Also, early adopters gain relevant expertise before it becomes mainstream, which is super important for anyone's portfolio when working in the industry. Also, I just want to note that it's really bad. It can be really bad at first, but just give it some time and learn to use it, especially with a paid tier. For example, I've been in the field since 2019, and even though ChatGPT came out in November 2022, I think I started really using it just in June 2023. So it took me maybe 6 or 7 months of hearing about it, learning about it, and even trying it out to finally figure out, oh, okay, I can use this for that, etc. So it can take time, and you have to figure out how it can be useful to you. Another reason why is that from a recent Anthropic study, so Anthropic, the company behind the Claude series of models, shared that 37.2% of all the requests they receive are for coding. And that's from only 3.4% of people that are developers from their audience. So that's just to show how useful LLMs can be for developers, which is why we built this course for developers to better use LLMs. So it just proves it's good. So just as an example, sales and marketing are only 2.3% of all requests Anthropic receives in the same study. But that comes from 8.8% of people. So it comes from even more people, but still it's fewer requests. Which means the people in marketing and sales don't really like ChatGPT. So there's definitely an opportunity to build something there, and for many other industries as well, where you can implement domain expertise and many other useful skills or useful systems around the LLMs to make them more powerful. And that's for why to learn to use LLMs. But why learning how to build with LLMs as a developer? Well, it's for many reasons again. But the most important one, it's because it can actually be linked to existing products and provide real value, which is something that is relatively new in the LLM space and even in the AI space. So it's very important to get going right away and as soon as possible. Also, LLMs are not good enough out of the box. Well, they are becoming better and better, but you can't often use them right away for your task or in your application. And fortunately, there are increasing ways to avoid or mitigate errors like hallucinations, including everything we'll cover in this course, like better prompting, retrieval, fine-tuning, implementing tools like web search, and more. It also brings a competitive advantage to your app if you implement it correctly, and you don't need huge budgets as you used to with AI. Big companies already train huge models. You can just leverage them easily. This is just something quite new, but incredible. Companies like OpenAI spend millions and even billions in training and making these models as best as possible, and they make it super cheap to use right away. So why not leverage that? Also, I guess the best point here is that any software developer can do it with some upskilling and practice, which we hope to provide here. Another reason on why to learn to build, or rather what we try to teach here, is pretty much what is called the AI engineering stack. So this comes from Swix, an interesting person to follow in the AI space. If you don't follow him already, he's quite everywhere, in fact. And he has a newsletter called Latent Space. It's also a great podcast to listen to if you want to hear about the news and better understand the field in general. But in any case, the AI engineer stack is pretty much a new subfield between a full stack engineer like ourselves, people working on product developers, and ML researchers, research scientists, ML engineers, the people that prepare data, train models, test models, do evaluations, etc., maintain models, etc. So basically, AI engineers is like the bridge between the two. They use APIs or sometimes models directly, so they need to understand a bit of everything. And so our goal here is to teach this bit of everything to the software engineers, but the course is not only to software engineers, obviously. It can be pretty beneficial to anyone. So we definitely invite you to keep listening and check out the other courses, even if you are not a developer. The reason why it's for developers is because we are talking about APIs and have some programming example using Python, but you can still follow along even if you are not a programmer or you don't use Python in a day-to-day. That's just because as we will see pretty shortly, the whole course is built in a half and half manner where the first half is always a bit more theoretical, but always useful theory to know in the field. It's not like math or less relevant concepts for an industry. We always try to just keep it the bare bones of things you need to know. And the second half is a bit more code related, but it's still a ton of industry specific tips and things we discovered while working in the field. So who we are to teach this. Myself, I'm Louis-François Bouchard. As I said, I'm the co-founder and CTO of Towards AI, and I used to be a PhD student at Mila and Polytechnique Montreal that was affiliated. But I'm from Montreal, and I was a student at Mila. I've also been an educator in AI since 2019, starting on YouTube under the name What's AI, where I used to share and explain research papers, which I did every week since I think late 2019 to early 2020, since maybe last year, where I left the PhD to focus fully on Towards AI and thus had a bit less time to read papers and cover papers. But anyways, I've been creating educational content around AI for many years, and now I'm fully dedicated into creating courses and educational content, still for artificial intelligence, but more focused on the industry now. And also, I've started working in the field since 2020 at a company, a startup, where I worked with Omar as well, called Design Stripe, which no longer exists. And after that, I worked for Towards AI, with Towards AI, my company, where we give consulting, we give trainings, etc. I will now leave my friend Omar Solano and colleague to introduce himself.
Hello, everyone. So, I will be the second presenter of this course. My name is Omar Solano. And just for a quick background, I'm currently doing a master's degree at ETS in Montreal, an engineering school. I've also worked in the industry since 2021, so mostly as a machine learning engineer and research for product development. And since 2023, I've been working with Towards AI on mostly technical writing and also some consulting on the side.
And who is Towards AI? Towards AI has been a publication on Medium. If you know about Medium, it's a place where people publish articles. And basically, Towards AI was a publication there where we have thousands of writers explaining AI concepts. It has been there since 2019 as well. But now we are transforming our company not into a media company only, but also an education company with our Towards AI Academy online learning platform, but also industry coaching, trainings, and consulting trainings like this one, for example, that we also give to companies directly in other styles and format where we adapt the course to the company. We also have tons of free resources like the Towards AI blog post that I just mentioned, my YouTube channel, the What's AI YouTube channel, few weekly newsletters, including the bigger one that is now followed by over 100,000 people. And as a fun fact, one of the followers is Jensen Huang, the CEO of NVIDIA, which was quite funny to learn recently when we were looking just for fun to company emails. So that's quite cool to know that Jensen frequently reads our newsletter. We also have the Learn AI Together Discord community with now over 75,000 learners. So that's always pretty cool to go to explain. So what is this course exactly? It's 5 sessions of 2 hours where each session, as I said, consists of 1 hour of like the essential theory to know given by me. And the second half is some applied theory that we call with some code examples given by Omar. By the way, if you have any questions, feedback, or whatever, please feel free to email me with the email right here, louis@towardsai.net. We are happy to help you out, build courses, give coaching. We take on many projects. And what's this course? It's 5 sessions to cover the fundamentals. The session 1 is this one, where we will cover foundational knowledge and how to use LLMs. So it's just a quick, recap or summary of how LLMs work, why they are so good, their limitations, their weaknesses, some prompting tips, coding assistance, security, etc. A lot of good bases to know when first starting. Then session 2 is about building on top of LLMs. We discuss RAG and the whole pipeline one company usually has to follow to build around LLMs efficiently. Then we go all about evaluations in a single course, covering everything you need to know about evaluations, which is, I think, or we think, the most crucial course of this whole series. Then we cover the one I think people love the most, workflows and agents with case studies, where we cover when to use LLMs, when to use workflows, how to build agents, and lots of stuff in this style. And then session 5 is kind of everything else you need to know, more about optimizations, monitoring, and advanced techniques, the things to know afterwards that are still somewhat crucial, but that didn't fit into the session 1 to 4. So we talk about optimizations that we may not necessarily use as an industry worker, but are still very relevant to understand, and you might encounter this in the near future. We'll also talk about vibe coding, how to stay up to date, and a lot of other useful topics. So, when are we giving this course? Well, it's today. You are following it already. And today's plans is as I said, AI theory, a quick review. We'll discuss the limitations, different ways to interact with LLMs, some tips for prompting, coding assistance, when to choose which LLM, etc. So it's very much the foundation for starting. If you are already well aware of that, you can skip to the lesson 2, which I think is extremely relevant for pretty much any future AI engineer. In session 2, we take you in the path of someone that is building a product using an LLM. Not using, but implementing an LLM in their application. And so we cover all the steps that they should be trying in order. And I think it's very relevant and very interesting. Before we start, I just want to mention that there's tons of jargon. Note that the slide is maybe not up to date here because you cannot really interrupt. But if something's unclear, let me know by email if you want, or you can just ask ChatGPT. I may often use different words for the same thing. For example, when we say that ChatGPT has 1 trillion parameters, this is often referred to as parameters, as I said, but also as weights, neurons, and other terms. So there are many terms that are interchangeable a bit, but I will try to make it as easy to follow as possible. So, some theory for understanding large language models without math or without code. So, LLMs fit in the AI landscape and inside machine learning. They learn to do things and are not programmed to do so, just like expert systems were. Expert systems, we basically had a bunch of if cases. So if something happens, do this or else do this, etc. And just bunch of them until we reach a decision. And this is all decided by the programmer or like the expert in the domain that tells the programmer what to do. Here, instead, we use neural networks, something vaguely inspired by the brain, to try to learn for us what to do in these kind of if cases. So it's basically replicating our expert. That's the whole goal at all time. It's also now leading the NLP field, but also unifies vision, speech, code, and everything. It's the first model, the first type of model, the LLMs, the transformers, that works for many modalities and super well. Here, a modality is just like vision is a modality, speech is one other, text is another, etc. So it works with a lot of them. LLMs also use the deep learning architectures. So here, deep mainly refers to the neural networks type that have multiple layers. So I won't enter into the details here specifically because it's not that relevant, but basically we have our input, which is basically what we send the model, our prompt, which will be here decomposed into each of these words. For example, here in red, we will have 3 words. Then we have our little arrows that process the information to the next layer. Without entering into the details, the technical details, here we are simply doing mathematical products of a weight, so a number associated with each of these arrows to the next neuron. For example, to the next layer, each of these bubble would be called neuron here. So for example, the first top left red input bubble would be the first word, like I, and then it will be sent to all the next bubbles in the hidden layer 1 in blue, just to tell each of these how much the I word is relevant. And then this process is repeated again, and it's just basically numbers multiplying numbers again and again. And so each of these lines that we see here is what we call a parameter or a weight. It's just a number, usually between -1 and 1 or 0 and 1, that multiplies the previous numbers to process the information in different ways. It's not really important to understand the full details and the full mathematical concepts and everything, but it's important to know that it only works with numbers, and it's basically just scalar numbers between -1 and 1 that decides of everything with multiplications and additions. So it all is pretty simple and just does multiplications in parallel for each layer, and then layer by layer, one at a time, sequentially. So it does many calculations in parallel, so you need lots of memory, and it also does them in sequence, so it takes time. So that's the deep in the deep learning. It's because we have multiple of these layers, hidden layers here, until we have our output layer, which is basically just the prediction of the next word or the next word to generate, the next word to say. LLMs also generate stuff, but they also understand it pretty well, obviously. This is why it's called generative AI. It's because it's not the first, but the first type of models to really be good at generating stuff versus previously where AI was super good at predicting stuff. In both cases, predictive or generative, they learn to represent data, a distribution of data, and understand it, quote to quote, just trying to predict what's the shape of the data, etc. With the goal of, first predicting it, but also to create new data similar to the ones that we have. For example, the predictive type of AI is like image classification or sentiment analysis. And the generative example, well, you know it already, but it's generating text, generating images, etc. There are 4 core components behind large language models that really make them work. And we'll cover them one by one right now. The first one is data. It needs 2 types of data. The first one is basically everything you can find. So it's the whole internet that people usually refer to, but it's Wikipedia articles, books, news, lots of code, etc. And the second type is something that we call fine-tuning, but we will dive in that soon. But it's basically curated examples of what we want our model to follow. And this is what is expensive to produce. This type of data is what is expensive to produce. The second core component are the tokens. So basically it's our input, which isn't text, because models don't know text really, they just know numbers. And those numbers are called tokens. We basically just have like an English dictionary, for example, and each word has an index where it is in the dictionary, and that's it. That's what the models see. It just sees these numbers that don't mean anything. So they need to understand it. And to understand it, they use embeddings. So these embeddings take the words, you make the token. So for example, here, if you follow cat, the cat is the token 9059. And then it produces an embedding. Here, each embedding is just 3 numbers. Like for example, cat, it's 0.256, 0.121, minus 0.552. That's not really important, but it just shows that there are multiple numbers that represent now each word. And why there are multiple numbers is because here there are just 3 numbers, but in reality it's thousands of them. And each of those numbers represents a characteristics that the model learned by itself to represent our world. So for example, the first number could be, is it big or small? The second number could be, is it alive or not? The third number could be, is it its color, like from 0 to 1, the whole spectrum of colors, etc. So it's all characteristics that ideally, when well trained, the embeddings will accurately be able to represent anything in the world. And if we plot it just in 2-dimensional here, for example, or 3-dimensional, we see that similar topics are near each other, like cat and kitten, but dissimilar topics are far away from each other. Like cat is far away from garden or from the, and with. The embeddings is basically the language of the model. So it's how they learn to represent our world. And so by using and understanding embeddings, we better understand LLMs, and we can leverage embeddings to do other things, as we will see. Anyways, it's just to say that embeddings are super essential here, because it's just, we are not even inside the model right now, and we are building its future language. So it's basically its whole understanding of our universe. So it needs to be pretty damn good, and then it will process it to understand multiple embeddings together. So that's just to show how useful and important are embeddings. Then we have a deep neural network. Here, it's always called the transformer. We always use this model as an LLM, but there are many others that exist. So what we've seen was we have the text, we send it to our tokenizer to make our token, then we transform it into our embeddings so that now it's ready for the model to take it. And our model is a series of decoder block that we call, which includes two crucial steps. First is the attention step, and then the feed forward step. And for example, we can have 20 or more of this block that repeats both these steps. And as a concrete example, DeepSeek, that was somewhat recently released, has 61 of these blocks. And we will dive into those two crucial blocks because they are what makes transformers what they are. So for the first one, the attention mechanism. The attention mechanism is crucial for the model to understand how each token should use each other token to better understand its context and where it is. For example, here we have the sentence, he sat on the bank and watched the river flow. And here, if we send just the word bank to the model, it might think that we are referring to a financial bank, but it's not the case just based on the sentence. So that's the role of the attention mechanism, is to put the sentence with the word itself together to have a global understanding of what's going on and be able to generate the next words by understanding all the others and their interrelations. Next is the feed-forward layer. This is also extremely crucial because it's kind of the brain of the model. It's basically a tiny neural network that we described before that will take each token and process it to make a new version of this token. So it kind of refines the token the deeper we go into the model. And here, just remember that each token has been transformed into an embedding. So our embedding at first is, for example, when we had the word bank, it would be the embedding of a bank. And bank can mean many things. So why do we want to transform it? Well, it's because we want to better understand that it's actually the bank of a river, not the financial bank. So we need those feed-forward layers that will transform each word representation, so the word bank here, into what it actually means in its context. This specific layer is pretty much the brain of the network, and it will be repeated with the attention mechanism to always complement understanding the sentence in the global context to improving the current understanding of each local aspect. And so we repeat that many times to finally obtain our prediction, which would be, again, a token, so our index, and then we find the word associated with it, which in this case would be in, which is our output. This is what we call our output. And then what happens is now we have, for example, if we read the sentence below to the right, is a long time ago in. So we send this whole sentence again to the tokenizer, embedder, then we process in the transformer with the many decoders, and then it generates again a second token. So we repeat the whole process for each new token that we want to generate. And this is why we say that transformers are auto-regressive. It's because they need to generate a token to generate the next one. So they cannot just generate a sentence one shot. They need to generate one word at a time and use the generated words to generate the next ones. So that's why it's a lot of compute, a lot of time, and why you receive a token in a streaming manner that we say, where you see one word appearing at a time as if it was speaking to you, but it's because it's generating one word at a time. And how do we get these models? Well, it's by training them on the data that we mentioned. And there are two main ways of training them that we'll cover right now. The first is pre-training. So we basically want to learn them how to write, how to understand the language, or like English in this case, and how to predict next words or the next sentences and next reply to say. And as a consequence of how it's made, with basically the whole internet lots of Wikipedia, etc., we are basically teaching it a lossy compression of the internet. Why lossy? Because while the models are enormous, the internet and the data that we have is way more huge, and we cannot memorize everything. It has to compress a bit. But this isn't enough. Just training on the internet isn't enough. Why? Because if we show here an example with GPT-3 that was just a model pre-trained like this, when we say the prompt, write a short poem about a wise frog, the model just give more instructions instead of replying or doing what we want it to do. And that's because in its training data, when it saw this type of sentence of writing something, it saw probably lists of in such instructions. I don't know why, but that can happen. And so the model is just doing completion based on what it has seen on internet. So it's basically an internet simulator where, for example, if with GPT-3 you gave a Wikipedia article and you gave it like half of it, it would normally generate the rest of the article almost as is. And that's because it has been trained on the internet and on these articles specifically, and not to understand what to do and how to answer. So this is where post-training comes into play. And here there are two main things that we do in post-training. The first one is called fine-tuning, where we use this data that we mentioned that is basically just a lot of examples of questions or queries, prompts by users, and ideal responses we want to have. This is used to refine our models for our needs or to follow what the user wants. It's the same thing as training, but we start with a pre-trained model rather than from scratch. We start with a very powerful model that already understands English and some things to do, and we just retrain it to make it much better at following what we want to do. And also, as I mentioned, it needs a curated dataset. So now, if we show the example, the version fine-tuned of GPT-3 is called Instruct GPT, and now it gives the short poem, the real one, instead of just a list of other instructions. There's also a relatively new things that we do that is called reinforcement learning from human feedback or from AI feedback, as with DeepSeek and Anthropic has been doing, which is mainly used to align the model. How? We do two main steps. One is to ask many questions to the model and ask it to answer multiple times. So we ask it to answer, for example, here we have ABCD, so 4 times. And then we pay people, or we use models, language models, to rate these responses from worst to best. And once we have this whole dataset built, we use another model and we train another model that we call our reward model to give this rating. So we basically train a model that can say if a response is what we want or not. And then we can use this new reward model to train our existing model with reinforcement learning and algorithms that we won't discuss in this course, but reinforcement learning algorithms like PPO and newer methods. And for example, it's no longer true, but ChatGPT used to always answer like this: a short introduction, bullet points, a short conclusion. Now it uses lots of tables, emojis, and other stuff, but basically that's what reinforcement learning did. It changes the way the model answers and gives responses, and is mostly used for better UX. It's also how many companies like OpenAI make the model learn to refuse malicious queries. It just gives lots of examples of when it cannot reply and how it should reply instead. And then we have a final part. After the pre-training and post-training, we have the inference, where we serve the model to users. Here we have many important components to make the model better for users, like streaming the tokens, as we say. So since we generate one token at a time, why not show it one at a time when it's ready so that the user already feels like it's getting a reply instead of waiting for the whole generation. There are tons of chat features as we see in ChatGPT, like the history, memory, etc. There are multiple types of prompts that we can use and provide the model, like the system prompt, the assistant, the user prompt, that we will all dive into in this course. And basically, these prompts, what we send, for example, the OpenAI API, are dictionaries, or a list of dictionaries if we have multiple interactions with the current role, whether it is assistant or user, whatever, and the content, so just the prompt itself. Then at Inference, we need to manage quality, cost, efficiency, small versus large models. We need also to augment LLM, as I said, with memory or other tools, code interpreters, calculator, etc. So that was a lot. So let's recap what's going on. We first start with a general knowledge LLM, something that has learned everything on the internet. And we have a tokenizer, which is, by the way, specific to each model. So that's pretty important. And so we are now able to take text prompts, transform it into numbers, process it into our model, and generate new text. But this isn't ideal. So we need to fine-tune it to get our instruction model. So something that can follow instructions. Then we can, if you want, train it further to better align it with our needs and add things like reasoning, for example, that we'll cover later in this course. We can also do, as Meta is doing with Llama, so distilling models, bigger models, into smaller ones, which we will cover how it works pretty soon. That's used to retain knowledge and increase efficiency. And finally, we serve it to user, where each new query is tokenized, embedded, and processed to generate a new token, and that is repeated sequentially, which means autoregressively, until the whole sentence is generated, the whole answer is generated. So the model generates new token sequentially, as I said, which means it simply generates one token based on the previous sent and its whole training data. It also means an LLM is a statistically powerful machine. It's not conscious and not intelligent. They are probabilistic, not deterministic, and so answers may vary even if you send the same prompt. It also remembers most facts if seen often in its training data, but it doesn't have memory or real memory by default of what you say it and all your exchanges. This has to be programmed into it with many tricks that we will also cover in this course. It also cannot tell the difference between truth and a lie, which can be a huge problem and limitation, which we will address in this course. And I put here asterisks everywhere just because that's mostly for now. Models are evolving incredibly fast. They are always better and better. And just for example, reasoning models came out a few months ago, and it improved models drastically. And so anyways, it's always improving pretty quickly. So those limitations are just for now. By the way, it's also all these reasons, the fact that they are not intelligent and they are just processing numbers. This is also why models are bad at jokes. Since they generate word by word, even if they have the context in mind of what to say next, they mostly work on the next word, the next token. So they are pretty bad at building suspense, anticipation, and creating a punch. Even if they can do that, they are not the best ones, mostly because they don't plan much ahead. But that has been fixed with many workarounds like the reasoning that we see, or implementing a memory directly, or like some planning steps. And so this all leads to our limitations. Since models are so powerful, one of the problems is that they are extremely powerful calculators. They process numbers, crunch numbers, understand numbers. They are not conscious, not intelligent. So that's one of the main limitation or weakness of LLMs is the what we call the hallucinations. That happens when the model produces confident yet factually incorrect outputs because of the way they work with next token prediction which is statistics. We had the example of the number of R's in strawberry. It's now fixed, by the way, but if you used to ask how many R's are in strawberry, the model used to answer 2 or a wrong number. But there are many fakes, and this is all due, by the way, because as we said, LLMs work with token and embeddings, so they were representing for strawberry as 1 or 2 tokens, and so it doesn't have the concept of letters. It cannot really count letters in each word. But there are fixes, like asking to do it step by step or to spell the letters beforehand, etc., or use tools like a code interpreter, where you just ask it to verify with code and it will spell the word and count the R's. There are also biases that all come during the training. It basically reflects all the stereotypes that are present in your training data, so every bias on the internet. For example, if you were to prompt to list typical professions for men and women, well, you would have the classic men stereotype jobs and women stereotype jobs. There's no real fix to that. You just want the best data possible and basically mitigate the biases that you don't want and focus on the biases that you want. Since every human, everything is biased, you can just try to have the best biases possible, like being nice, respect others, etc. Those are all biases that you may want to have in your application. And to do that, you need good data and you need to pay people to produce them. Another limitation is the knowledge cutoff, which is basically the last training data point beyond which a model is no longer updated or trained. So when we do the pre-training and post-training, as we said, we do it once or multiple times, but we do it. And once it's done, there's no input anymore into the model. It's not modifying its weights, its parameters, as we said. It's just fixed there in time. A quick fix is to give it access to more data, like the internet, for example. Likewise, the knowledge that you need to use may not have been in the training data of the LLM, like speaking another language or trying to have answers in another programming language. Well, if the model hasn't seen it during training, it might not be able to answer pretty well. And to fix this, you either need to retrain your model or fine-tune it, what we call fine-tuning, or use what we call RAG. So add retrieval to your system with your own data. Another limitation is the limited context window of models. The context window is actually the number of tokens that you send to the model. So we have a limit of the maximum number of tokens that you can send at once to the model, which is usually in the hundred of thousands of tokens, up to 1 million or 2 million in the case of Gemini. Just to note that larger windows do offer more context, but are costlier, slower, and they are not perfect. For example, Gemini or Google with Gemini uses infinite attention, and it basically works like usual, processing 100,000 or so tokens at a time, but then at each step it condenses information to send it to the next one. So we lose this information, just like zipping a file or compressing an image to make it a bit blurry. We save space and we can send more information, but it's of lesser quality. And so the fix here, the problem here rather, is called the needle in a haystack, where this is a type of benchmark that we use to measure how well the model do with long context. But the problem is that this needle in the haystack is basically like an answer that you are trying to find in the whole book. Well, this needle appears quite flashy in the context. It's not like a subtle thing you are looking for. It really flashes and the model can find it more easily. And another issue is that there aren't multiple related needles that we can evaluate on to understand if the long context actually work. So for example, if we send a book and ask everything to know about Robert, models are pretty bad at that. Just because there are things to know about Robert at page 1, page 10, page 500, and they cannot really do that pretty well. And to do that, we instead need to divide and conquer. So we need what we call RAG that we will cover in the full second course. Another limitation is that LLMs are not intelligent. They struggle with basic logic, like for example, counting the letters R in strawberry, or here, very basic example, asking it to add 1 plus 0.9, then it says the right answer. But if you say, oh, isn't it 1.8? It will agree and say that it's 1.8. So it doesn't has like an opinion and truth. It just follows what you say. So that can be pretty dangerous, by the way. And another example to show that it's a bit stupid or not conscious and intelligent is when you ask which is bigger, 9.11 or 9.9, it says that 9.11 is bigger because basically 11 is bigger than 9. So that's totally false. And it's because of multiple reasons, but most importantly, that the model is overfitting to memorized examples rather than doing true reasoning. And this is fixed with what we call reasoning or using external tools and obviously improving models. Just as a quick example of how someone can fix those limitations, I have here how OpenAI or ChatGPT addresses these limitations with ChatGPT. So first, it's by having lots of curated data set, and then by paying lots of humans to do RLHF or reinforcement learning from human feedback as well as possible. Then they integrate many tools like live web search, they integrate RAG or Retrieval-Augmented Generation, which is basically document ingestion. They allow for custom fine-tuning for domain-specific expertise if they don't know your language, for example. They are increasing token limits over time, which lots of companies do. And they have bright patches for other problems, like, for example, summarizing chat history to make it more condensed, but keeping the crucial information instead of relying on the math inside the model to do it. They do advanced techniques like prompt caching, which is basically to pre-compute the text that you send often. So as I said, when you send a prompt, it's always tokenized and embedded. So here we will do it once. And if you send the same prompt, big prompt, like sending a PDF multiple times, it will do once and then reuse the computed embeddings when you ask new questions. They implemented user memory for better user fit, which, by the way, can be turned off. That can be interesting because in my case, it finally knew that I was a YouTuber, and it started, I don't know why, to always answer as if it was a YouTube video. So they always said like, good morning, this is my name, or whatever. It always had the style of a YouTube video, even if I just asked a random programming question or whatever. So it was pretty annoying. I turned it off and it was all fixed. So if ChatGPT starts acting weirdly to you, that might be a nice fix. They implemented many useful tools like the code interpreter for better math. They implemented Canvas, which I don't use anymore, but when it first came out was pretty interesting for code and text. I believe it may not be available for O3 and reasoning models, but I would need to confirm. But in any case, this used to be interesting where I, for example, here highlighted a word, asked to do something. Here it's in French, but bear with me. I was just asking to better explain JSON before mentioning it. And so it edited the only paragraph and provided an explanation of what a JSON is before referring to it. So it's pretty useful to edit only specific places in your text or code. And finally, they are working on reasoning models that fix a lot of issues that we'll talk in the session 5. And now quickly, I want to cover the AI landscape just because I always hear like things like, the model ChatGPT is super powerful or whatever. I just want to say that first, ChatGPT isn't a model, it's an interface. And so this is why this whole slide. So first, we have companies in the field. So the main one would be OpenAI, but there's also Google, Anthropic, DeepSeek, and others, which usually have two types of interface. The user interface, which is the one that most people know about, ChatGPT, or Gemini, Claude, DeepSeek, etc. And there's the developer interface, like the playground or the AI studio, the console, etc., where developers use APIs and communicate with models. And those models that are also in ChatGPT, that are both in the user interface and developer interface, are the actual model. For example, GPT 4.0, 4.0 mini, oh 01, now it's like oh 03, oh 04 mini. We also have developer-only models like the GPT 4.1 series that is super useful. But there's also, as I said, Gemini models, Cloud models, DeepSeek models, etc. So this was the last slide from me. I'll now leave Omar to talk about the second part of this first session. Since you are watching this on YouTube, please consider checking the full course on the Towards AI Academy, where if you liked this first hour, you can benefit from 9 more hours of useful concepts that are way more applied than this first foundational theoretical lesson. So if you enjoyed it, please check out the Towards AI Academy for the full course. Also, we offer consulting, coaching, and training. So please reach out to me either by DMs or to my email, louis@towardsai.net, for any queries or any questions. I'd be happy to chat. Now, let's get back with part 2.
All right, so for the second part of the presentation, we will start with the different ways to interact with LLMs, then some prompting tips you can use, some tips around how to use LLMs as programming assistants, how we can choose LLMs depending on the task. It's going to be some high-level information, which we will go more in depth in the next few classes. And finally, some points around security and confidentiality. So for the 5 ways to interact with these models, of course, we have the public-facing chatbots. So services like ChatGPT, Claude.ai, or Google Gemini, for example. They all have some sort of free tier where you can use the service for free, but you're pretty limited in terms of how many times you can interact with the chatbot. So they also offer these subscription models where you can pay and increase the number of interactions you can have with these services. Then if you're a developer, you can also use these AI models with public API endpoints. So you have, for example, companies like OpenAI, Google, or even third-party inference companies like Together AI or Grok, where you can basically use these models through APIs, and then instead of paying by subscription, you pay by the number of input or output tokens. If you need a little bit more privacy, so this is better for enterprises that need more security and privacy for their use cases, then you can choose these private API endpoints. So you can, for example, use Azure, OpenAI, or even Amazon Bedrock to use these models in a more private way. So that's another way you can use these models. And of course, you can also deploy your own models to different GPU cloud providers. So you can either go with Google Cloud, Amazon Web Services, Azure, or even smaller companies like Lambda Labs, where you can deploy open models. And since we have the access to the weights, the model weights, we can deploy the models. And then we can, for example, with this way to use LLMs, we're going to pay mostly by the hour. So we are going to be renting these GPUs. And here I give a small example. So for example, if we use the full precision Llama 70B, then we are going to need around 80 gigabytes of VRAM. And that's about around $2 an hour on Lambda Labs. So that's another way we can interact with these models. Then, of course, the other way we can use the models is to simply deploy them locally if you have the hardware to support it. Mostly, it's not very cost effective to do that unless you already have a product and you have a lot of users that need where you can serve those users. And in this case, for the same model, so Llama 70B, you could buy two 100 cards with 40 gigabytes each, and it's going to cost you around 23K. So it's not cheap. Now, if we talk about prompting, of course, you have the simplest technique, which is just zero shot prompting, so just an instruction. Here, for example, I say, translate this statement into French, and the chatbot, the AI model is going to be able to translate the string. So this is the simplest way you can basically prompt these models. Then more performant ways to use them is to basically do what we call few shot prompting, where we add some more instructions, maybe some relevant context of the task, and examples of the task being done within the input prompt. So in this case, we can see that following the simple instruction here, we add more examples, and we also add the correct output format that we want the answer to be in. So this is very useful when you have a well-defined task. And yeah, basically, we always recommend to add more instructions and to well define your tasks whenever you're prompting these AI models. Then you have role prompting. This can be useful in some cases. You're telling the model to react or to write in the form of a persona. So, for example, here we can tell it to act like a pirate. And so here we don't need to tell it exactly what a pirate does because it already knows what a pirate is. So the model can already act in the correct way. So, for example, you can also tell it to be an expert in marketing. And instead of trying to write all the possible correct instructions, if the model already knows what a good marketer does, then the model is going to be able to write correct marketing copies, for example. So this can be useful in many different ways. Then you have chain of thought prompting. This is more useful for models that are non-reasoning models. So we will explain what a reasoning model is in the next few presentations. But basically here we want to give these non-reasoning models the instruction to reason about how to find the answer before answering it. So for example, if we tell it to do a math computation, we tell it to write step by step what will be the different steps to solve the problem, and then we will tell it to answer at the end. This is very useful because it gives the model more tokens, more time to find the correct answer. It's the same. You can think of it like humans, where we need to write down the different steps to get to the correct answer. So maybe we can do it first shot, but the task becomes way easier when we simply write down the different steps and reason with the steps to find the correct answer. So whenever you're prompting these models, we recommend that you always tell these models to think, to write down the steps before they give the correct answer. Then the fifth and last prompting tip we can give you is to use advanced frameworks to basically automatically optimize the prompts that you give to different AI models. Here you can use tools like DSPy or AdalFlow to do it. It's a little bit more complex to set up. You need, of course, to code the optimization flow and also to provide a way to evaluate the prompt. So an evaluation function. But using this, you can basically make sure that you're optimizing to the limit whatever task you're doing. So we recommend that you check out these tools. So for some key principles, we always want to treat prompts like code. So you might want to use version control to optimize the prompts you give to different AI models. By doing that, you're going to be able to iterate on them. It's going to be easier to roll back or optimize in a more scientific way, let's say, the input prompts. You can try different tools to do this. You can either use more, let's say, established services like Microsoft Prompt Flow, or you can use simpler tools like Prompt Layer or even Langsmith to do these kind of things. Then, of course, it's very useful to write whatever instruction you're giving to these models to write them in a way that is very clear and very concise, so the models don't deal with ambiguities. Here, a good communication is always going to be good, basically. And also, whenever you're working on writing a prompt, to not forget to add all the necessary context. So you can think of it like giving, trying to get help from a coworker, and you give it as much context as possible to be able to be helped, and so that they don't get stuck or don't really understand the task you want to complete. So here it's going to be very useful to add all the context that they need, and also, of course, to be explicit, to avoid implicit assumptions. So these models, maybe even if they seem very intelligent, sometimes they can make wrong assumptions. And if you're an expert in a field, then it's going to be very useful to be explicit about them and guide the model as close as possible to extract the most performance you can from these LLMs. All right, so now let's talk about how we can use these LLMs as coding assistants. But before we do that, I thought it would be interesting to see exactly how programmers think about these tools and how they are using them since they basically came out. So here we have 5 insights from a survey that GitHub did back in September 2024. And for the first insight, we can see that for 97% of them, so basically all of them, they have already used AI coding tools. So we basically see that AI tools are no longer a niche thing. It's now something mainstream among developers. For the second insight is that in terms of how they boost productivity or creativity, here we see that for American developers, they basically now spend more time collaborating with their team members or designing better systems for their product instead of spending time, for example, doing code reviews or even taking breaks. And for the other countries, we see that it enables developers to spend more time learning, or even researching and experimenting with new technologies. So AI enables developers to basically make it very easy to adopt new programming languages or trying to understand new code bases. And that's what we see here. So for the majority of all the developers in the USA or even in Brazil and the others, we can see that developers find it very easy or even easier to understand new code bases. So that's how AI is helping them in their work. Then for security and quality, for 90% of them, they think that it enables them to write better secure code, and that basically it's going to be better for code security. Then in terms of adoption, we can see that the American developers are more encouraged by their companies to use this new technology in comparison to countries like Germany, where developers are a little bit less encouraged to use them. So we see here a gap between these countries, very interesting. And the final insight from the survey is that for basically 100% of them, they believe that using these AI tools will make them more employable over time. So very important to start using them right now, so we can be more, basically employable, better performing using these tools. Now, for the first strategy or method that we can employ to get better performance out of these tools, of course, is just to use the automatic code suggestions tools that we can use. So basically, many services already provide them. So you have GitHub Copilot, you have Cursor Tab, and Windsurf, and many other tools. They basically allow you to accept automatic suggestions, and it can make it faster to write code. So we always suggest that you turn on this feature, and it will make it a little bit faster when programming, basically. The second way, which is not automatic, is to basically prompt directly the model to help you write a function or whatever you're working with. So here, instead of getting the automatic suggestion, we write a prompt, a question, whatever you want to see, and the model will try to answer the best it can. So here, for what model to use, here we recommend that you check out benchmarks or even leaderboards. So here I put the example of the Web Dev Arena leaderboard. I'm going to come back to this later. But basically, whenever new models come out, sometimes new models are way better for programming. So you can try to experiment to use them and then get better performance out of these tools. So yeah, we recommend that you check out the Web Dev Arena leaderboard for that specifically. Whenever you're chatting with these models, it's very useful to basically understand different code bases. So if you're trying to understand a new code base here, the cursor chat with code base will make it very easy to get up to speed, basically. So then here, another way to use these models more specifically is to use them as code and documentation explanation tools. So here, tools like Cursor with the chat with codebase feature is very useful for that. The tool will try to retrieve all the relevant context, and then the model will have all the context to answer your question, basically. So whenever you're trying to understand a new code base or you're trying to understand the documentation written by your coworkers, here with AI models, it becomes really easier to do that, basically. Then, of course, you can use them to write documentation. So here, it's very important that you actually understand how the code functions, so you can fix whenever a model didn't write the documentation correctly. But using these models as first draft or even to just start writing the documentation here, it becomes very useful to do that. So you can write Markdown, whatever you want to write. Of course, you can use them for refactoring or even improving the code you're writing. So here you can ask it to provide different ways to go about implementing a feature. You can ask it to make a class or a function more concise. Here, it's very important that you still read the code, whatever the model is writing, to really try to understand what is being written so you can still modify the code and understand it. And of course, you can use more agentic tools. So we will go more in depth in the third session on how agents work. Agents are something more recent that you can use. So here I list some of them, but basically these tools allow you to hand off some task, some implementation to these agentic tools, and these agents will try to implement the feature the best they can, basically. But we need to keep in mind that since they are writing more code and you're not actually giving them more guidelines or instructions, there's more probability of errors. But they're getting better over time. So even if they're not perfect now, we can expect better performance in the following months, following years, basically. So if you're trying to use them, then we recommend that you still prompt them in a way that reduces the amount of errors. So first, you're going to ask for some planning. So before they write any code, to ask them to come up with a plan. Then they can start implementing the feature. Then you're going to read whatever they wrote to validate that the code looks correct and the feature looks well implemented. And then you're going to execute the code to see if there's any errors in the generated code. For these kinds of tasks that require more autonomy and less human input, you can check these kind of benchmarks. So you have Bench, for example, that you can check out. Basically, the agents are trying to solve GitHub issues. And here you can see that the first system solves about 64% of all of those issues. So we can see that it's not perfect, but it's getting better over time. Now, some best practices to make it clear. We want to prompt them with clear requirements and iterate and refine the prompts. And of course, we want to read, understand, and validate whatever the models generate here, because we don't want to end up with a code base we don't understand and then we cannot debug. So here, of course, human expertise is still valuable. And yeah, what we want to avoid, we want to avoid generating large code bases that we don't understand. Basically, even if the tools are very eager to provide a lot of code and implement things right away, we always recommend to not do that, to try to generate as small chunks of code, to read it, understand the code, and then keep going. So now if we switch to another topic on basically what's different between open or closed source models, and going about it by seeing different metrics. First we can categorize these two types by three different categories, basically. So we have the proprietary models. So all the models you cannot deploy yourself. You don't have access yourself to the model weights. So all the models by OpenAI, for example, or Anthropic or XAI. Then you have companies that are willing to share the weights of those models to everyone. So here you have companies like Meta, Llama, Mistral, DeepSeek that provide all the model weights. And then, of course, you have the models that are completely open source. So we're going to go point by point now. Okay, so let's switch to another topic now. Now we're going to see basically what's different between open and closed source models by looking at different metrics and categories. So we can categorize these models by three different types. So you have, of course, the proprietary models, the open weight models and the completely open source ones. So we're going to go one by one. So for the proprietary, here, these models, you can only use them with paid APIs or web interfaces. So you cannot host the model yourself. These services are usually not completely private. So for example, if you use the models of OpenAI through the API, then OpenAI is going to keep all the data for 30 days just to monitor for abuses. And if you want to use proprietary models, but in a more private way, then you can consider the private API endpoints that I mentioned at the beginning of the presentation. So you can check out Azure OpenAI or Amazon Bedrock. And for people using chat services like ChatGPT, then I just want to mention that you can opt out of letting OpenAI use your conversations for model training. So if you look into the settings, you're going to find this toggle, improve the model for everyone, and you can either check it or uncheck it if you want OpenAI to use your conversation, basically. Now for the open weights category, here are the models that you basically can host yourself. By hosting them yourself, you can ensure complete privacy, of course. But here it's important to note that model replication, here I mean creating a replica of the model, is not possible because these companies do not share the training data that they used and the training recipe that they basically use to create the model. For these kinds of models, you can either host them yourself on GPU cloud providers, or you can use third-party LLM providers. Here I have a graphic showing all of the different companies that you can basically use if whenever you want to use an open weight model. And if you want to see more updated figures, you can go to this website, artificialanalysis.ai, which does a very good job benchmarking and comparing either LLMs or these third-party LLM providers. So it's a very useful source. Now for the third category, you have the completely open source models. Here you have the training data, you have a detailed technical, basically a detailed paper, a report. And by reading the report, using the training code and the training data, you could replicate the models. So create a clone or replica of the model they released. And this is mostly useful for academics or people trying to improve on these AI models. So this is a very useful distinction between open weight models and open source models. Now, if we look at the models themselves, we can look at different metrics. So we have the cost per token, we have the context length, the model performance on different key benchmarks. We have their features, their capabilities. So if they can process images, voice. We also have the latency. So that's more about like the latency during inference. You can also look at if you are able to fine tune them or not. And then you can try to look at things like tokenization or even vocabulary to differentiate these kinds of models. So if we look at the cost per token, here we can I show a basic graph that shows how the cost per token has diminished over time. So we can see that a year ago, 2 years ago, GPT-4o was quite expensive, and now it's almost 240 times cheaper. So whenever you're trying to choose a model based on cost, it's always going to be something temporary because by seeing the trend over time, we can see that these tokens are getting cheaper over time. So this is something to keep in mind whenever you're either building or using these tools. So here I show another figure where we can see that actually the Gemini models are quite cheap relative to their intelligence. So for the most intelligent model, we can see that it's right now it's Gemini 2.5 Pro, and it's quite cheap. So the x-axis shows how cheap it is compared to other models. So we want to be on the right here to be cheap, and high on the y-axis to be smart. And you can see basically that all the other Gemini models are cheap compared to their intelligence. So this is something that is very like snapshot in time. So whenever you're choosing something on a model in the moment, you can look up these kinds of figures and make your decision based on these figures. Now, if we look at context length, we can see the same thing basically. Back when ChatGPT was launched, we only had GPT 3.5 with 4K tokens of context length. Now with GPT 4.1, it can process 1 million tokens, and you also have Gemini 2.5 Pro with 1 million tokens of context capacity. So yeah, again, when we're building either applications or just using them as tools, we can predict that in a few months, in a few years, the context length will continue to increase. But we need to keep in mind that, as we saw in the first part of the presentation with Louis, that the performance can actually decrease as the number of tokens becomes large. So even if the models can process a lot more tokens, we don't want to include irrelevant context, irrelevant information, because it could confuse the models, it could reduce the performance of whatever task you're trying to get done. So that's something else to keep in mind. Now in terms of model performance, here you can look at different key benchmarks. So this is just trying to see, this is not about whatever feature you're building. This is just trying to see, okay, we have all of these models available. Which ones are the ones that seem the most smart, intelligent for whatever use case I'm trying to build. So here we recommend that you check out the LM chatbot arena. So this is basically just a way, they provide a way for people to vote on what model provides the best answer. So you give it an instruction, and then you get two answers, and you can choose which answer you like the most without seeing what model is answering you. And by gathering all of this data, but by a lot of people, then the people at LM Arena, they can compute this ELO score that you can then use to try to see, okay, here for the web dev arena, we can see that most people right now prefers to use Claude 3.5 Sonnet. So yeah, whenever you're, for example, coding and you want to know what model to use within VS Code or Cursor or anything like that, you can check out the web dev arena or things like that. Now, for these benchmarks like MML LU Pro, these are questions on related to the STEM field. This is just to see how intelligent the model is in mostly scientific type of questions. It might not be relevant for your use case, but it's always, I guess, good to see what type of model is most intelligent in these kinds of questions. Then we have more specific benchmarks. So you can see, for example, the benchmarks provided by Scale AI, the company at San Francisco, where, for example, they measure things like agentic tool use or coding more specifically. And these are questions that the models never saw. So you can be sure that the models were not trained on those questions. And then, yes, you can use all of these kinds of benchmarks to see what are the models that are most intelligent. And here, for example, you can look at the things like the Artificial Analysis Intelligence Index, where they try to gather all of these different benchmarks and compute a single score. And it can be useful if you don't want to look at all of the individual benchmarks. So here you can have a single score to compare all of the different models. Then, if you're actually building something related to images or voice, then programming tasks or coding tasks might not be useful. So you can look at things like the vision arena, where people actually prompt the models with images, for example. And here you can see that actually Gemini here is the best model for that. So it will depend on your task, but it's useful to compare all of these models on different benchmarks or arena here in this case. Now, in terms of latency, here it's mostly related about how fast you can get an answer from these models. Here you can see that O3 is the slowest model to answer you because it produces a lot of reasoning tokens. We will come back to reasoning models in a next presentation, but it's normal to see that on the right. And here, if we are building applications that require a lot of latency here, basically, very low latency, then we want to choose models on the left and look at the y-axis for the intelligence metrics. Now, if we look specifically at Llama 3.3, then we can compare all of the different companies that are able to provide this model. So we can see that Cerebras is actually the fastest company to provide for Llama 3.3, but it's also the most expensive. So here it's all of these figures are from artificial analysis, and I invite you to check them out if you're trying to choose an LLM for your use case. Then, if fine-tuning is something that will be required, then the possibility to fine-tune LLMs becomes something important to consider. So with fine-tuning, we can benefit from higher quality results. We are able to reduce the size of the prompt because the model already kind of knows what the task will be. And so by reducing the size, we can save on token costs and by consequence also lower the latency. But we will talk more about this specifically in the next session, but we recommend that you only consider fine-tuning after you tried simpler techniques like prompting or even RAG before trying to train an LLM. And why we say that? It's because the time, the cost of training can be quite large, just in time, for example. And we also know that newer and intelligent models keep coming out, token costs keep getting lower. So fine tuning can become something not very efficient to do. So if you're trying to fine tune LLMs, we actually recommend that you use the fine tuning services of proprietary models like the OpenAI fine tuning service, where you don't need to set up all of the hardware or renting the instance with a GPU to do so. You can just provide the training data and then iterate on the hyperparameters to get the best performance. But it becomes easier to train, to fine-tune a model using these kinds of services. So for example, if you use the OpenAI fine-tuning service and you have 100 tokens in your training dataset, then you're going to pay by the tokens. You're not going to pay by the number of hours renting a GPU. So if you train GPT-4o mini, for example, over 3 epochs, so 3 times over the training dataset for all the examples, it's only going to cost you 90 cents. It's going to be actually quite cheap to fine-tune your model. So in comparison, if you rent an instance, a machine, a server with a GPU, it could cost you about $2 an hour on Lambda Labs. And if you multiply that by the number of hours, it can become really quite expensive compared to the other service. Now, if we look at tokenization or vocabulary, and more specifically, you can consider basically this metric, this factor, if your task requires you to use LLMs in a different language other than English. Because, for example, if you look at the French arena, so if you go back to the LM arena, you can choose the category of French or whatever language you're trying to see. And here you can see that different models become, the rankings, it can really be different here. So here in on this figure, on this screenshot, we can see that actually Grok 3 is the best in the French language, followed by GPT-4 latest, and then the other ones. So whenever you're optimizing for or you will use the models on a different language, here it can become very useful to look at these kinds of benchmarks. So here I just list quickly the most intelligent, the most used key closed models right now, but it's going to be changing in the following months, following years, of course. And the models that are open weight, so all the Meta, Mistral, Google, DeepSeek models. And then for some key trends, we see that a larger context is a trend. So models keep getting more and more context. They can process a lot more context for each release. And then if we combine that with context augmented generation or cached augmented generation, it can reduce cost and latency. So we will go back to that in the next session, but we see that larger contexts become something that keeps getting bigger. Also, the models no longer work with only text. Most of them now can process images, videos, audio, and that enables them to become way more useful for more types of application. Here I listed 2 examples. So you have OpenAI Operator that can control a web browser, or the Anthropic computer use tool that can let a model take over a computer. So this is very interesting, and yeah, basically it enables more types of applications. Then, of course, you have the reasoning models that enable the latest agentic type of application. You can see that with the OpenAI Deep Research on ChatGPT, that is very good. Basically, the models become way more autonomous. They are able to use tools on their own, reason about the results of the tools, choose to do different actions, and these kinds of tools, they can be very powerful and save you a lot of time. So this is something to keep in mind. And if you're trying to build an application, then these reasoning models can really be useful for that, to build agentic applications. Then you have these small distilled models. So even if the models, the most intelligent ones right now are very big and you cannot use them on your local hardware, you still see some small models that can be used on small devices like your smartphone, and they can be actually be good enough for simple tasks. So if you're just trying to translate something or rewrite something, then these small models can be good enough for that. And yeah, companies still release these kind of small models. Now, if we look at some points about security and privacy, so in terms of data privacy and security, you need to keep in mind that services like ChatGPT or Gemini are not actually private. So you need to be aware that if you're sharing private information, then it's going to be seen by those companies. So if you're using the ChatGPT app and you're providing private salary information, for example, then yeah, of course, OpenAI is going to be able to see that, and you need to be aware of it so you don't actually provide that information. Then, like I said earlier, if you use the model through the API, for example, the Open API, then OpenAI will retain the data for 30 days. And if you use tools like GitHub Copilot, then all the engagement data, the accepted or discarded suggestions, will be retained for 24 months to improve the service, basically. So the code it's suggesting, the code that you're writing, basically, is not private. Then, of course, if you're building your own application, it's going to be important to control what the LLMs can see or not. So if you're building a RAG application, a chatbot application that can connect to a database, for example, we want to put some controls in place so the model that cannot access the all the data within the database. And it's going to be important to log the interactions that the LLM is performing. We will come back to this in the final session where we talk about jailbreaking and yeah, jailbreaking. Basically, what are the jailbreaking methods right now? So yeah, it's going to be important to keep an eye on these access control topics. Now, in terms of guidelines, if you're in a company, it's going to be important to have a guideline. So be aware of what is allowed or not to be shared with tools like ChatGPT. Then for output management, it's going to be important to keep an eye that you're responsible. If you're building an app on top of these models, that you're responsible for handling the hallucination problem. So you want to be clear with your users if you're building an application that these kinds of models have limitations, and you're actually documenting and yeah, keeping an eye on these types of risks and try to mitigate as much as possible the bad outputs of that the models can output, basically. So if you're building on top of models, you're actually responsible for the AI outputs. So you need to be complying with the privacy regulation. And also, you need to be aware that the models have vendor terms or licensing requirements. So if you're using models by Meta, for example, you need to make clear in your application that the application is powered by Llama, it's built by Llama. And if you're a big company, you have more than 700 million monthly active users, you will need to ask permission from Meta before using the model yourself. So yeah, like I said in the previous slides, we are responsible for what we show to the users, even if the system doesn't, we don't own the actual LLM that the system uses. So we always need to make sure that the system, the application, the feature always comply with security policies if we have security policies, that the system maintains consistent quality, that we detect potential quality issues very early in the development, and that of course that we meet the business requirements. So we will see this more in depth in the evaluation session that we will do in this course. But basically, we need to implement at least a basic structured testing approach. So making sure that we have some sort of evaluation process to catch those issues early. Of course, we need some metrics. So those will depend on the type of task that you are doing on your application. And of course, we can also build automated validation pipelines. So things like using other LLMs to judge or anything really to make sure that the outputs the system is producing are correctly evaluated and validated before they are sent to the users. And so that's it for today's session. I hope you like it, and I hope you learn some useful things for whatever you want to build in the future.
Hey again, I just want to remind you that this is the first 2-hour session of our 5-session course that is hosted on the Towards AI Academy platform. So please check it out if you found this first 2-hour useful, and purchase the course to get the next 8 hours and learn everything an LLM developer needs to know. We might also have the second one on YouTube, so please subscribe and stay tuned to see it for free. But the rest, the session 3 on evaluations that we think is the best one, and the 2 others on agents and optimizations and much more, will stay on the Towards AI Academy.